Hello, again this is unit number 2. We're starting at lesson number 3.3, which is found on page 149 in your book. Alright, and so we're going to start with this one right here. It says a table represents the relationship between the base, length, and the height of some parallelograms. Both measurements are in inches. Alright, so just to refresh your memories, parallelogram just simply means that this side and this side they are parallel to each other, and that this side and this side are parallel to each other, right? And because of that, we know that this length and this length are the same, this length and this length is the same, all right? And what they're giving you here is they're saying the table represents the relationship between these, all right? And they want you to go ahead and try to figure out a mathematical operation that we can go and use for this, okay? So it says table represents the relationship. What's the relationship between the base length and the height of these parallelograms? So we want to somehow figure out a way to go and relate the base and the height for these parallelograms. Well, if you look at these, you notice it goes 1, 2, 3, 4, 6. Okay, so this is always going up. And then at this other side, it's always 48, 24, 16, 12, 8. These are always going down. Okay, so this tells me that this is what's known as an inverse relationship. As one goes up, the other one goes down. If they're both going up or they're both going down, that's going to be a little bit different relationship that you have between the two. But because one goes up, one goes down, that means there's going to be an inverse relationship. And I'll show you how that manifests itself here. So if you look at this, 148, 224, 316, 4, 12, 6, and 8, you should be able to recognize the fact that if I multiply these two together, I get the same number every time. I get 1 times 48 is 48, 2 times 24, 48, 3 times 16, 48, 4 times 12, 48, 6 times 8, 48. So what we can do with this is we'll just go and say, oh, well, look, this is what this parallelogram is. Here's our base, here's our height. And if I take the base times the height, I get 48 each time. That's essentially the equation that we're working with here. Now remember, I promised you that we're going to have an inverse relationship. So if you just wanted to solve for base on one side and have height on the other side of the equal sign, how do you get it there? Well, if you look at this, what's actually happening between the base and the height? Excuse me. Well, you have multiplication going on. Okay, if I want to get it all by itself, I have to undo multiplication. And how do I undo multiplication? Well, I divide. All right. Well, I want to get base all by itself, which means I got to divide by the guy I want to move. So I'm going to divide both sides by height. All right, height divided by height, boop, that goes away. And I just get base equals 48 divided by the height. Now this is what I was referring to as the inverse relationship. As this gets larger and larger and larger, whenever you have a fraction that the denominator keeps getting larger and larger and larger, that makes the whole thing overall go and become smaller. So when this goes up, this whole thing goes down. And since that side is equal to that side, that means that that goes down. So the height increases, the base goes down. If you went the other way, if the height went down and became smaller and smaller and smaller and smaller, all right, that means this overall side is going to go up and become larger, which means that since these two sides are equal, this side has to go up. So the height goes down, the base goes up. All right, so they're inversely related to each other. All right, let's go down to our next little problem here. It says visitors to a carnival are invited to guess the number of beans in a jar. You've probably done something like that before. Just the number of pennies in a jar, a number of jelly beans or something like that. The person who guesses the correct number, wins $300. If multiple people guess correctly, the prize will be awarded evenly amongst them. What is the relationship between the number of people who correctly guess correctly and the amount of money each person receives? Well, it's pretty straightforward. I mean, if you want to figure out how many dollars that everybody's going to get, remember, let's look at this from the standpoint of units. Essentially, what they're asking you for is how much money would each person receive? What's the units that they're asking for? They're asking for how many dollars per person is going to be happening there. That's the units that they're looking for. All right. So I know what the dollar amount is. All right. That's 300. It's $300. Now the number of people that tie, we don't know yet until we actually count all this stuff up. But that is represented by the letter P. All right. So recognizing what the units are that you're looking for helps you to figure out how to actually express this mathematically. Okay. So we go down here, and as you can see, what we have here is the amount of money that each person receives is $300 divided by the number of people that you're talking about that actually tie. This bottom one, number 3, a half-gallon jug of milk can fill 8 cups. Yes, half gallon has 8 cups, while 32 fluid ounces of milk can fill 4. Okay. What's the relationship between the gallons and ounces? Okay, what's the relationship between gallons and ounces? So on this one, we want to figure out gallons versus ounces. That's what they're asking for. What's the relationship between gallons and ounces? Well, they kind of gave you some clues here. Let's go and look at the first clue. The first clue says a half gallon of milk is 8 cups. So a half gallon is the same amount in this universe as 8 cups. All right? The quantity on top and the quantity on the bottom is the same thing. It's a ton of brick versus a ton of feathers. It's the same thing. It's still the same amount of stuff. So this is a conversion factor. All right? This is a special type of unit analysis. All right? We can use this. Since both sides have units, I can use this thing. Now, I could go and put it the other way. I could say that there's 8 cups in a half a gallon. It's the same idea, all right? That's why I have, this is not equal sign. This is like, is equivalent to saying 8 cups is the same thing as a half a gallon. Now, they go on a little bit more and they say 32 ounces of milk can fill 8 cups. 32 ounces, 8 for 4 cups. So they say 32 ounces is 4 cups of milk. Well, just like I did up here, I can kind of rearrange this thing and I can say, well, that's the same as, kind of the same idea as saying 4 cups is the same as 32 ounces. Oh, okay. So now, so now I have a bunch of units here and all kinds of stuff that I can play with. Let's see what we can fit together here. What are they actually asking for? They want to know the relationship between gallons and ounces. Gallons and ounces. Well, where do you see gallons at? Well, there's the gallons. And over here they got the ounces. Okay. So we want to go and try to figure out how many gallons are in an ounce or how many ounces are in a gallon. Okay. Well, I like to go and figure out how many ounces are in 1 gallon. Because if I consider ounces is a small amount, so it will have a large number. Gallon is a pretty good size of volume. Obviously, a gallon is bigger than an ounce. So I'm going to put the big one down here. That way I'll get a nice big hefty number up here. All right. So if you look at this thing, I want gallons. Well, I can't get gallon on the bottom using this one, so I'm going to cross him off. I'm going to use this one because gallons are in the bottom. All right. So I like this one. I like 8 cups per half gallon. All right. And now I'm halfway there. I got to get from cups to ounces. Well, if I have cups up here, I need to get cups down here. And I want to have ounces up here, so I have to have the ounces up here. All right. So I got to go and pick one of these two, where the ounces are on top and the cups are down here. The cups go down here because I have to cancel the cups. I want the ounces on top, so I have the ounces here, and then they'll work out for me. So if you look over here, what do you have? Hey, well, we have 32 ounces for every 4 cups. Oh, okay. The cups will cancel for units, and now I have ounces per gallon. All right, so let's look at see what that is. Well, let's see. I've got a 4 and a 32 and 8 and a half, and if you want to go and think of this as 0.5 for now, that's fine. We don't normally put fractions in here, right? Now you can represent this another way, then there's nothing wrong with that. When you've seen how we use this one, if there's 8 cups in a half a gallon, how many cups are in 1 whole gallon? This is another way that you can manipulate these things, right? Well, if you got a half gallon and you want to go to a whole gallon, you got to double it. That means if you have 8 ounces, you'll need, or 8 cups, you'll need to double it. So that's the same thing as saying 16 cups in a gallon as opposed to 8 in a half. So if you want to put it in like this, if you want to say ounces per gallon, and I say, well, I just got done figuring out that there's 16 cups per 1 gallon. So 16 cups for 1 gallon. And I know that I got 32 ounces in 4 cups. 32 ounces in 4 cups. Ounces. All right, and the cups still cancel. That's perfectly acceptable. And now you avoid the whole trap of having a half down there, having a 0.5, anything screwy like that. Now I just do them numbers. Numbers are a little bit more familiar to you. So is there any way that I can go and reduce this? Remember, I got a 16, I got a 32, I got a 4, and I got a 1. Well, how many times does 4 go into 16, for example? Well, 4 goes in there 4 times. So I can factor a 4 out of there, you get a 4, I factor 4 out of here, I get 1. Now I got a 1 and a 1, and remember, what's 1 times 1? Well, that's 1. And whenever I have a fraction with a 1 in the denominator, poof, it goes away. It's divided by 1, and it has no meaning anymore. So you ask yourself, well, what's 4 times 32? Well, let's see, 32 times 4. 4 times 2 is 8. 4 times 3 is 12. Oh, there's 128. So what does it turn out to be? All right, ounces per gallon. Ounces per gallon, you have 128 ounces, right? Ounces per gallon. And you are done. That's all they're looking for there. Okay. Now, they have a little bit more of an expansive view here. They have like cups and ounces over here. And that's fine. I mean, you can do a lot. You can play around a bunch of different ways. This is my favorite way to do it. Just simply working with conversion factors. And I can play with the conversion factors a little bit. There's multiple ways to write conversion factors, right? Remember, these are fractions. They help us to kind of organize our thoughts and convert from one unit to another unit. So this is all kind of nice and handy dandy, right? And that's all there is for 3.3. You have a little bit of a summary on the next page. I'll let your para take care of that. But from this, we'll move on to our practice problems.